Okay, so this is a review of Unit 9 of AP Stats, which is all about like scatter plots and slope lines. But we're going to be just going over like test taking procedure basically. So there is 4 parts to every FRQ answer in stats, and I'll be going over each part like one by one. To start, we have state, right? These are the stuff you want to put at the very beginning of your test to just make sure you get like all the credit that you need. So I'm going to be separating this into 2 parts. You have your significance test for slope of least square regression line and confidence interval for least or for slope of least square regression line, which I'm just going to refer to that as LSRL from now on because there's no point in taking out this whole long sentence when I can just abbreviate it. So anything in yellow is LSRL significance test, and the pink ones are confidence interval. So let's start with the significance test. What you want to have is your null and alternative hypothesis, and you have B is equal to 0, or B is, and that's for your null. For your alternative hypothesis, you want to have that B is not equal to, more than, or less than 0. So this is your slope of your least squared regression line, right? And you want to have it in context specifically. So your slope will tell you if there's like a relationship between things. So for example, like height and shoe size, for example, that would be a positive slope. Your B value would be greater. Now, let's say age after 50 and height, that would be a negative relationship because as you get older, you get shorter, unfortunately. Now, you always want to have it in context. So your sentence starter for slopes or for B would be the slope for the population regression line relating to y is equal to the y variable in context to x is equal to the x variable in context. So, for example, we have a study trying to find out if there's a relationship between distance from the target in meters and bullet hole distance from the center of the target in centimeters. So if I'm shooting my gun really far away from a target, my bullet hole will be most likely farther away from the target. So the study will probably have a hypothesis saying that B is less than 0. You have a negative relationship. Now, if we're trying to talk about it in context, we would write B would be the slope of the least squared regression line relating y is equal to bullet hole distance from the center of the target in centimeters, and x is equal to the distance of the person from the target in meters. Also, you want to state the confidence level, or you want to state the alpha level in significance tests, as well as the degrees of freedom. With this one specifically, you won't have your degrees of freedom, which is the number you have minus 2. So if I had 30 participants, I would have a degrees of freedom of 28. Okay, it's just that simple. Just subtract 2. Super easy. Now let's talk confidence interval for slope of least square regression line. You still want to talk about your slope in context, okay? Your whole thing right here stays the same, and your degrees of freedom, you also want to mention that. But there's no need for your H of O or H of A. You do want to put down your confidence level, however, not your alpha level. Now let's talk plan. This is the same for both significance test and confidence level. We're going to use the acronym LINER, which stands for linear, independent, normal, equal standard deviation, and random. So for linear, you're going to look at your scatter plot. If it looks linear, you're good. If it doesn't look linear, you're probably not good. You want to check your residual plot to see that there's no curved pattern. So you're either going to have a residual plot given to you, or you're going to have to make your own. And you're going to check your residual plot. And if there's like a pattern of like a parabola or like x to the power of 3 or like an exponential, just anything, that just means that, oh, this doesn't work. We can confidently say that this is not going to work. We're not going to be able to carry on with this. Now, independent, same as always, the number you sampled is less than 10% of all people who could have been sampled. So for example, 20 babies is less than or equal to 10% of all babies, right? Pretty simple. Normal, you're going to make a histogram of your data, or you're going to be given a histogram, and you're going to make sure that there isn't any clear skewness or departures from normality, right? So just imagine what a normal like graph would look like, and if it looks normal to you, then we're good, right? No outliers, no weird things. You don't want to be like too strict though. If there's like a little bump somewhere, like a small little like unevenness, don't just rule it out like, oh nope, this could never work, right? It has to be like pretty obvious, like a huge spike at 35 when your median or your mean is like 4, something like that. Equal standard deviation, you want to look at your residual plot, and your vertical spread should be roughly the same. So to put this in perspective, you're going to have like a line like this, and you're going to have a straight line through, and you're just going to have a bunch of dots everywhere. That's what something good would look like. However, something that would look like bad is when you have a bunch of close dots close together, and as you get farther and farther away from the origin, they get farther and farther spread out like this, right? That would be an example of something that wouldn't work. You want to have a bunch of little dots that look like, you know, that like Instagram comment thingamajig that looks like it says like no correlation. You want that. Now, random, that's usually given to you. Don't worry about it. There's no real way of like calculating that. Random will be given to you most often, usually. Now let's talk do. For confidence interval, you're going to be given B and the standard error of B as this number or this number, right? If you have a table that looks like this, like, okay, so just divert your attention to here. You're going to have a table that looks like this, where it has term, coefficient, standard error coefficient, t-val, p-val, constant, rho, standard error, and like all these other like boring stuff. The ones you want to focus on are these two right here. These are the important ones, all right? You have your rho, which is going to be at the top of your coefficient, and your standard error of the coefficient. That's what these two things are. Now, it's going to be equal to B, which for this example would be negative 1.117, plus or minus T star times the standard error of B, which is 0.947. Now, what is T star? So T star is the, you're going to find that through doing inverse T. So you're going to enter the area of one tail and the correct degrees of freedom, and then you're going to paste it, you're going to enter it, and you're just going to, enjoy. For example, let's say we have a alpha level of 10. Okay, so we have a confidence level of 90. Or actually, no, we could just stay in our alpha level. We have an alpha level of 10. If we're just doing one tail, or we would have an alpha level of 0.10. Our one tail would be 0.05, right? We're cutting in half is the idea. Sorry to make that all roundabout. That would be your T variable. So let's do that again with 95 as our confidence level. That would make our alpha level 0.05. Divide that by 2, you have 0.025, right? Just like that. Anyways, you'd have that, and then you have your correct degrees of freedom, which is, as we know, your number minus 2. You then put that into this equation, and you will get a range from one number to another number. And if you haven't already written it down, write down confidence interval for a slope of least square regression line. Next. Significance tests. So you're going to have to find your t-statistic first, and that's equal to this number divided by this number. Forgot to highlight it, but it is your standard error of statistics is this one right here, okay? So for example, in this specific scenario, it would be negative 1.117 divided by 0.947. So that is your t value, and you want everything to the left of that in this example, right? So if I had b is less than 0, we'd be looking for everything to the left of that. To find the area or like the p-val, we'd have to put in t CDF. For example, for this one specifically, we have a lower bound of negative 99999, an upper bound of negative 1.18, because that's right here, and we're trying to find the area in between that. We'd also put down our degrees of freedom, which in my example is 28. So we calculate it and we get 0.124. Now, let's say we have something that's like positive. Okay, so we have instead of t being negative, it's like positive 2. Positive 2. So we have a lower bound of 2 and an upper bound of 9999999. And then we have our degrees of freedom would stay the same. However, let's imagine that b is not equal to 0, okay? It's not greater than, it's not less than, it's just not equal to 0 at all. And we're just looking for, is there a relationship? So if we're just looking for a relationship, you want to multiply your number by 2. Okay, that's all you want to do. That's basically saying, oh, we're checking from here to here, and then same thing on this side. That's all you're doing. And if you haven't done it yet, you're going to write significance test for slope of LSRL. Now let's go to conclude. Let's start with our confidence interval. We are confidence level % confident that the interval from blank to blank captures the slope of the population regression line relating y equals y variable in context to x equals x variable in context. This, you've seen this before. The fancy part here is captures the slope of the population regression line. Okay, that's the new thing. Significance test, because the p-value of blank, let's start with the blue one specifically. Because the p-val of blank is less than the alpha level of blank, we reject we reject the null hypothesis. We have convincing evidence of a positive or negative linear association between y variable and x variable in the population of, and then you have to name your population. So you will know from your alternative hypothesis whether it is a positive or negative linear association. So if I had b is greater than 1 or greater than 0, then I would have convincing evidence of a positive linear association. But if I had b is less than 0, then I would have a negative linear association. Now let's say it's not equal to 0, okay? We just have no clue. Then we'd say we have convincing evidence of a linear association, okay? Forget about positive, forget about linear. It's not and or, it's just convincing evidence of a linear association between y variable and x variable in the population of, name your population. So if we're going to do like height and shoe size, the population could be all people who wear shoes. Now let's go to, we're like failing to reject, or the pink one. Because the p-val of blank is greater than the alpha level of blank, we fail to reject the null hypothesis. We do not have convincing evidence of a positive or negative or just in general linear association between y variable and x variable in the population of, and then we name our population. So that's all you really need to know for AP Statistics, Unit 9. I wish you luck on your tests. Good luck.